John, are you going out for basketball this year?
No.
Do you want to do the DAC board at all this winter? Because you can say no if you want. You know? Okay. That's fine. Just wondering. Okay. Let's look at a PowerPoint here first. Okay. The last ones is the mathematics of finance. So we're working with interest and annual percentage rates and loans and things like that. All good stuff. All stuff that Mrs. Olson will teach you better about. But we'll look at simple and compound interest. Interest compounded a certain number of times per year. Interest compounded continuously. Annual percentage yield, which I'm not very good at. So, yeah. So we'll work our way through that. Future value and present value. Future value of annuities. Yeah, I'm iffy on that. And loans and mortgages, I'm a little iffy on that. So the teaching part will go really slow for those three things. So I try to make sure I get them taught to you the right way. But the first top three, oh yeah, I'm golden there. Okay. Interest compounded annually. If principal is invested at a fixed interest rate and calculated at the end of the year, the face value after n number of years follows this formula. Amount equals the principal times 1 plus the rate to the time power. N is time and years. Okay? So that is like other exponential functions that you've had this chapter. Okay? So that shouldn't be anything too scary. Okay? So compounded annually. That's 1 time per year. Suppose George Milligan invests $5,000 at 5% annual simple interest, and Quan Lee invests $5,000 at 5% annual compound interest. Compare both values of the investments after 10 years. Simple interest. Simple interest is this. The amount equals the principal plus PRT. That's simple interest. Simple interest, the amount in the end equals the principal plus the principal times the rate times the time. So the amount in the end for George, this is George here, is $5,000 plus $5,000 times 0.05 times 10. Calculadora, por favor. Somebody take 5,000 times 0.05, which I think is $25 times 10 would be like $250, right? So this would be $5,250 using simple interest. He got 5% over 10 years' time. Now, compound interest, compounded 1 time per year, is the amount equals the principal times 1 plus the rate to the time power is $5,000 times 1.05 to the 10th power. You'll see that Quan Lee makes out like a bandit in this situation compared to George. So 5,000 times 1.05 to the 10th power. What is that? $8,144.47. So Quan Lee makes almost $3,000 in George just because when it is compounded. Okay? The more times, so what is compounding? Well, compounding is saying, okay, after 1 year, this is how much interest you have. So after 1 year, what's 5% of 5,000? Like $250 or $25, right? So at the end of the first year, she has 5,000. No, maybe it's 250. Take 5% of 5,000. Is it 250? Yeah. Okay. So at the end of year one, she has 5,250, and he has that at the very end. But then at the end of year two, you take not just the 5,000 times that, but it's the 5,000. So is this right?
Would that be 7,500?
Yeah, it's probably 7,500. There, that's more like it. So at the end of year one, which still makes a $600 difference, okay? At the end of year one, when she calculates the interest, it's off the $5,250. This one still is off of the $5,000. Okay, so it gets $250 a year for 10 straight years. This one, first year is $250, second year is probably $270, third year is probably $290, and so on. Okay, because it's compounded off of a different number. This is compounded off the same number each time. This one is taken from a different number. That's compound interest. Okay, so the more you have it compounded, the better off you are. Now, if it's compounded more than once a year, then you use this formula. And K is the number of times it's compounded per year. K is the number of times it's compounded per year. Okay, so we're going to take an example, and we're going to even do more than the number of problems that they tell us to do. All right. Suppose Paul invests $400 at 8% interest compounded monthly. Find the value of the investment after 5 years. So we're going to do monthly here. So it's 400 times 1 plus 0.08 divided by how many months are there in a year? 12 to the 12 times 5 power. 12 times per year times 5 years. So it's being compounded 60 times. But you take the interest rate and you divide it by 12. But the taking it to the 60th power makes up for the dividing this by 12 type of thing. If you do that in your calculator, what do you get for monthly? So it makes $195.94 in interest. Okay. If you did just simple interest, if you take 400 times 0.08 times 5, and then add that number to 400, what would you get? 400 times 0.08 times 5 plus 400. What did you get? Nobody? $560? Sounds good to me.
Kind of low, no?
Well, that's just using simple interest.
No, you like the compound one, you know?
Compound is $195.94, but you only start with $400. So that's not a lot. What if it's compounded more than that? You should get more money, right? Let's say it's compounded daily. How many days are there in a year? So let's do this. Let's take 400 times 1 plus 0.08 divided by 365 to the 365 times 5 power.
596.7.
7 what? 70?
Yeah. 70.
So you make a little bit more on daily. How about per second?
Wait, but when did he doing it? When did he doing it? Like 350 something more times.
Yeah, but when you're working with a low amount of money at the start, it doesn't show that big of a difference. Now, let's say that's instead of $400, let's say it's $400 million.
I've got it
Per second. Okay, the formula would be 400 times 1 plus 0.08 divided by how many seconds are there in a year?
31 million.
Roughly 31 million.
Yeah.
To the 5 times 31 million power. So it should be 596 still?
596.729.
0.73, basically. Yeah.
So you make
So
3
only more 3 more cents if you compound per second. Could we compound it even faster than that?
Wait, but if you're adding 8%, 31 million more times.
But you're dividing the percent, you're dividing your rate by 31 million too. So that rate is super, super tiny. And so that's where the trade-off is.
These diminishing gains are kind of reminding me of an asymptote.
Mm-hmm.
Which I suppose.
Yep, and this is exactly where we're getting with this. If we do it continuously, we don't use this formula. You use an E, because E is a natural logarithm. So if you take 400 times e to the 0.08 times 5 power, and this is why natural logarithms are useful in the real world.
Is that really how you spell
continuously? Yeah. If you do the math on this, what do you get? 596.73, right?
So pretty much the same as doing it every second.
Yeah. Okay. So, yes, between monthly and continuously, for this small amount of money, the difference is less than $1. But you can see it is more, okay, than what you would have. All right. No, per second it is slightly different, but continuous. I mean, they are so close to each other, it's basically about the same. But continuously is an easier formula, much easier formula, much quicker to get it. Okay, so this is continuously. This is a certain number of times per year. Okay, so you need all these formulas written down somewhere because I don't have them on the board anywhere. Okay. So make sure they're written down so you can do your homework today. Okay. So simple interest is just the amount. So simple, the amount in the end equals the principal plus the principal times the rate times the time. Just straight like that. But then compounded a certain number of times per year is that. Compounded continuously is that. So I'll give you just a few seconds if you haven't written them down yet to write them down. All right. So we already did that one. 596.73. Okay, that's what we just did just a couple seconds ago. Okay, this is now where I start getting a little foggier. The common basis for comparing investments is annual percentage yield. The percentage rate that compounded annually would yield the same return as the given interest rate with the given compounding period. Okay? So if it's compounded annually, you're comparing it to how it's compounded another way, and that's the annual percentage yield. All right. Suppose you invest $15,000 at 6.25% compounded monthly. So then you go 1 plus 0.0625 divided by 12 to the 12th power, because it's 12 times 1, because we're doing per year. Okay? What do we get as an answer to this?
1,596.48.
So then to figure out the APY, you go 1,500 times 1 plus the rate to the 1 power, so it's really 1 plus the rate, equals 1596.48. Okay? Because we want to figure out what is their actual rate if it was compounded yearly. Annual percentage rate for years. Okay. So what I would do is I'd just go 1,500 plus 1,500 R equals 1596.48. Subtract 1,500. So 1,500 R equals basically 96.48, and then divide by 1,500. So the APY, annual percentage yield, is what? Take 96.48 divided by 1,500.
Is this a percentage or
Yes.
6.432%?
6.432%. 6.43, whatever. Yep. Okay.
So if you
Now,
know the rate, then why would you try to find it?
okay, this is the rate compounded monthly. We wanted to know the equivalent of what, if you was compounded one time per year, what it would be, which is 6.43% if it was compounded yearly. Okay?
So does that mean it's better to compound it yearly than monthly? Or
No.
what does that mean?
What this means is if you got this interest rate compounded yearly, it's the same as this interest rate compounded monthly. You're comparing interest rates.
So it's showing you how much better monthly is to
Yeah.
It gives you the same number.
Yes, you're getting the same number. You're just figuring out what the difference of the rate would be if it was compounded a different way. So this is like a comparison thing. This is how bankers use as a comparison. Okay. And they do their problems a little differently than what I did there. I think my way is simpler. So when it comes to if you had to help me solve this, it might be a different way than what I just did there. Okay? Don't get confused by that. All right. Future value. That's when you invest in something. That's when you make an investment in an annuity or whatever. The future value tells you how much it'll be worth after a certain amount of time. So future value is this equation. Okay? I would write this down. This is important. So future value equals the N is a number of payments of a certain number of dollars. And I don't know why they use R instead of P. They should have used P, not R, but they used R. Okay. And then the interest rate appears both there and there.
So that's just the rate. That should be R2.
That's the interest rate. But they used I's there and a capital R there. So, yeah, it's a little confusing. Okay. But that's future value. Are you all right with? You got this written down. Okay.
Or the N for time.
N is the number of payments. Because you pay into an annuity every month. Okay. And you want to know what the value will be at a certain time after making so many payments and so on. Okay. The present value is this formula where you've invested with investing so much. Here's the interest rate, and this is the number of equal payments, and it's to the negative power because it's like we're going back in time. Even though it's a present value, it should be worth this. What is its present value? So if they say, well, in 20 years, you'll have $1 million. So then what is your value right now to get to that $1 million? Carlos purchases a pickup for $18,500. What are the monthly payments for a 4-year loan with $2,000 down payment if the APR is 2.9%? So this is your interest. This is your number of times, but monthly payments is, N would actually be 4 times 12, which would be 48. So N is 48. This is that. So he gets a loan, $2,000 down payment. So his money, so we got to figure out the monthly payment. So we got to figure out how much he's paying per month. Okay. So you take 1850 minus 2,000, 18,500 minus 2,000 is $16,500. That's basically what his loan is for because he puts $2,000 down. Okay, that's his loan. He has to pay 2.9% interest. So they give him $16,500 to pay for the pickup. How much does he have to pay back to the bank? Okay. Okay, so this is the present value one. So we've got to use a present value one because he gets this amount right now. Okay, he gets this amount right now in the loan. So present value, PV, equals, what's our formula? The last one you wrote down.
P times 1 minus, in parentheses, 1 plus R, parentheses, the negative N exponent over R.
You changed the letters, didn't you? Yeah. Okay. So I think, we got to figure out what R is. Okay. The amount of money he has to pay back. So presently, he gets $16,500. We got to figure out what he has to return to them, how much he has to return. So you take 1 plus 1.029 to the negative 48th power over 0.029. All right. So you figure out this number. So if we figure out this number, okay, and then, because this will be a crazy decimal, and then we take 16,500 divided by that. I'm just going to change slides here. Okay. Oh, they did it a different way, but his monthly payment will be $364.49.
Isn't he just paying off $2,000 though?
No, he's paying off $16,500. He makes a down payment of $2,000. So he pays right at the start $2,000, plus he gets a loan from the bank for another $16,500. Okay, so he has to pay back the bank this amount, this much per month. Just take this times 48 once. Just take that times 48. What are you going to get?
$17,495.
5.2. Okay. So basically, for letting him use $16,500 of the bank's money, he has to pay the bank back almost $1,000 in interest over those 4 years. Okay? So that's how banks make money. That's how banks operate. Yes. They flip things around. So what I would do is I would take this all. So I'd go, let me borrow your calculator. See if it works out for me. On. So I'd go 1 plus parentheses 1.029 raised to the 48th power, negative 48th power, divided by 0.029. Yeah, yeah. See how I said I was a little bit foggy on this stuff? That's
future value.
come on. Okay. Now this isn't working, so I'm going to escape. Escape. Discard. All right. So if we go back one, this is the, oh, Mr. Bierschbach, the interest, since it's the annual percentage rate is 2.9, I have to divide that by 12 to figure out the monthly rate. So that is where I went wrong. Okay. So, yeah. All right. We'll look at that when we look at this. All right. So, looking at the problems on 3.6. All right. Oh, really? All right. Find the amount after this interest rate is compounded annually and for simple interest at the same rate. So in the first problem that you do, you're going to take, let me get a less fat marker. You're going to take 2,200, and this is compounded annually, times 1.04 raised to the third power. And you're going to compare it to the simple interest, which is $2,200 plus $2,200 times 4, or 0.04, times 3. This is simple interest formula, the amount plus the interest. Interest equals principal times rate times time. Where compound interest once per year is the principal times the 1 plus the rate to the time power. Okay, that's how you set up those. Now, if it's compounded monthly, 12 times per year, the way you'd set it up is 1,800 times 1 plus 0.07 divided by 12 to the 12 times 6 power. That's compounded monthly. That's how you'd set it up. Okay? If you compound continuously, it's 3750 e to the rate 0.069 times time times 7. Okay? So that's the different ways of figuring out interest. Simple interest is here. Compounded once per year is there. Compounded monthly is there. Compounded continuously is there. Here's another compounded continuously, which is the same setup as that. All right. Now we get to the fun ones. Find the periodic payment of R of a loan with a present value of $15,000. The annual interest rate is 6.6 for the term of 5 years, with payments and interest charged 12 times per year. Okay, so you set the $15,000 here equals, and then it's 1 plus, right? Or it's 1 minus? Present value, yep. 1 minus, and there's an R here. 1 minus the interest, which is 0.066 divided by 12, because you're taking it 12 times in a year, all over, wait, is this in parentheses? Wait. See, I can't remember that formula. Because there's a 0.066 over 12 down here, too. Because that's an I. Wherever the little I's are, is this. So it's 1, but is this by itself taken to the power?
Yeah.
Or is it there's 1 plus 1? Because I forget the stupid formula. And it's not on here, is it? No, it's not. All right. Formula. Oh, this is your handwriting. Okay.
Wow.
Okay.
Wait, so when should you use future value since you're finding his payments
but you've got the loan right now, so they've given you the money now. The future value is what will it be worth in the future. I'm sorry, it's confusing. I know. All right, so this is 1 minus, and then parentheses 1 plus this.
Really quick.
Yep.
So a present annuity would be like you gaining an amount of money and then paying it off over time. But a future annuity would be
You're putting money into an account every month, and you're figuring out what it will be worth in the future.
Like a Roth.
Yeah, like a Roth IRA. Yeah. It is good not to ever take out a loan, but someday you might want a house or a car that you know, whatever. But if you can buy a car without taking out a loan, that's a good thing because you save a lot of money. Okay, so let me see. Boom. Okay, I'm going to try this on my calculator. So I'm going to figure out the top of this. Second, quit. Clear. So I'll go 1 minus parentheses 1 plus parentheses 0.066 divided by 12. Take that inner parentheses to the negative 60th power. Oop. Raised to the negative 60th power. Delete that. Okay. So that should be the top. 1 minus 1 plus that. Boom. Uh-oh. An overflow error. That's not good. Well, let's see if we can divide this by 0.066 divided by 12 parentheses. Let's see if we get an answer. Nope. No. Yours worked? So let me see what you typed in and see what you got. Holy smokes, 76. But you put the 15,000 in front.
We're not supposed to?
No.
Just do it again and delete it.
Just delete the 15. Just enter that. Get rid of the 1,500. So, yeah, see.
We should just get this back.
All right. Because I'm doing something wrong. And I don't understand what I'm doing wrong.
you can't teach us it. Can you pass it on?
Yes, I can. Okay, so I'll adjust the assignment because, like I said, I struggle with that. Yeah, but you gotta.
I don't know. I just did all that was there and then divided it by 1,500 to solve for R.
Yeah, and that would take 15,000 divided by that, and that's 294, which would be the answer.
So Ron is right.
Because if we go down here to the answers on that, $294.20, just like what Ryan had. So if we take 15,000, so for yours, we take 15,000 divided by that. Yeah, we get the right answer. So we are doing it right.
Ryan, we almost got out of the problem.
Yeah, blame John. Okay, so we want to find R here. So we take this side divided by this side, right? So we take $15,000 divided by parentheses, 1 minus 1 plus
Wait for his bill.
0. No, wait a second, Belle.
Please come to the office, Ainsley Allen.
And then that is divided by, so then that is divided by, let me see if I can, it'll work in my calculator. Okay, so let me try one more time. So I'll take clear, because mine is an older calculator here, and it might not be able to do some highfalutin math that we got here. 1 minus parenthesis 1 plus 0.066 divided by 12 parenthesis to the negative 60 or raised to the negative 60th power parenthesis divided by 0.066 divided by 12 parenthesis equals. And we get the right answer. So if we get the numbers in right, it'll work out. Okay.